Hi everyone. Today we are starting section 3.2, the derivative as a function. In the previous section, we learned how to find the derivative at a single point. But now we are going to extend that idea. Instead of just finding the derivative at one point, we want to define a new function called the derivative function. This derivative function tells us how the original function is changing at every value of x in its domain. So instead of getting just one slope, we get a function that gives us the slope everywhere. Let's look at the definition. The derivative of a function f of x is a function defined by f prime of x equals limit as h approaches 0 of f of x plus h minus f of x all over h. Let's talk about what this means. Inside a fraction, we have f of x plus h minus f of x. This measures how much the function value changes. Then we divide it by h, which measures how much x changes. So the whole fraction is calculating the average rate of change. When we are taking the limit as h approaches 0, we are shrinking the change to be extremely small. That gives us the instantaneous rate of change. In other words, it gives us the slope of the tangent line at a specific value x. So, the derivative function gives us the slope of the tangent line at each value of x. Next, we say a function is differentiable at a value a if the derivative exists at x equals a. That means the limit we just talked about actually exists. If that limit exists, then the function has a well-defined slope at that point. Now we extend that idea. A function is differentiable on an interval if the derivative exists at every point in that interval. So if the derivative works for all x values in that interval, then the function is differentiable on that entire interval. Now, let's try an example. Find the derivative of function f of x equals x squared minus 2x using the definition. This is the derivative definition, so we want to use this definition to find the derivative. First, we need to find f of x plus h. Since f of x is x squared minus 2x, replace every x with x plus h. X plus h squared is x squared plus 2xh plus h squared. Negative 2 multiplied by x plus h is negative 2x minus 2h. And there's no like terms in this expression, so we stop here. Now, let's plug into the definition. We'll substitute f of x plus h with x squared plus 2xh plus h squared minus 2x minus 2h. And we'll substitute f of x with x squared minus 2x all over h. Now, let's simplify this expression. First, we need to distribute the negative sign. So negative of x squared minus 2x becomes negative x squared plus 2x. All over h. Now, let's combining like terms. X squared minus x squared is 0. Negative 2x plus 2x is 0. We'll end up with 2xh plus h squared minus 2h all over h. From the numerator, we'll factor out the common factor, in this case h. So we have limit as h approaches 0 of h times 2x plus h minus 2 all over h. Now, cancel the h. Next, we'll take the limit. I'll substitute h with 0. And I have 2x plus 0 minus 2, which is 2x minus 2. Therefore, the derivative f prime of x equals 2x minus 2. This means that for any value of x, the slope of the tangent line is given by 2x minus 2. Notice I keep the limit notation throughout the process until I actually substitute h equals 0. Please do not forget this. It is important to keep the limit notation if you are not ready to substitute yet.